So welcome to the first webinar in our series of webinars for Deltec Homes. We're really excited to have you here, and hopefully it will be both informative for you as well as informational. One thing that I wanted to mention is we are excited because we have viewers from all over the US as well as from Europe, so welcome to this seminar. We are presenting this from our different home offices in New Jersey as well as North Carolina. So appreciate if there's any technical issues or something like that, we're obviously trying to do this from our home offices. The other note is that this webinar will be available to you. So if you want to look at it afterwards, it'll be recorded and available and sent to you to your email address. So if you want to see it again, we will have some time for question and answers afterwards. So feel free to type in your questions in the bar on the right. And then at the end of the presentation, we'll get to as many questions as we can. Before we start, we'd like to give you a little bit of background on Deltec Homes. Many of you know us, some of you do not, but we think it will give you some context in terms of kind of why we feel we're uniquely positioned to help you as you think about home building and sustainability within home building. We were started actually by two brothers in Asheville, North Carolina in 1968. One brother was an engineer, and the other brother was an entrepreneur. And really, I think what that means is that we, from our very core, are an engineering company that manufactures and builds homes versus just a builder. And so engineering and kind of precision is kind of built into every home that we have. We also started off in commercial registry or commercial building commercial resorts. And so we fully understand kind of how multifaceted and complex larger projects can be. But where we actually really became known was when we shifted our focus to residential construction and building custom homes for people such as yourselves. The other thing we've done is really been recognized for building our hurricane-resistant homes. Many of you may have seen us on the Weather Channel or other media showing where our homes have withstood some of the most extreme hurricanes out there, including Dorian in the Bahamas fairly recently. And so kind of we have the ability to really understand and build those hurricane-resistant homes. But one thing that we're especially proud about is that we've continued to innovate, and that includes, sustainable building practices, which is obviously why a lot of you are here today to listen to Leigha talk. So we're very excited about that. Where we really have expanded is rolling out the additional housing types, to really incorporate sustainability and efficiency into all of the homes that we do. So the 360-degree homes or our hurricane-resistant homes, certainly include a lot of sustainability features into them at the level at which you want them. But then in 2012, we rolled out the Ridge Line, where that took and incorporated a lot of what we learned in sustainability into a specific style that a lot of our homeowners like, which then followed by the solar farmhouse in 2018, which was due and kind of developed in terms of customer demands for style of house that's very popular in today's world. So certainly a range of homes, all of which contain a lot of our precision engineering and as well as our sustainability inherent in them. We're also a certified B Corp corporation, kind of recognizing the importance of holistic business practices as well. And where we stand today is that we have over 5,000 homes built, located in 50 states, in over 30 countries and 5 continents. In fact, some of our recent builds have been shipped to the Bahamas recently. We had a building that was shipped to Palau fairly recently, and we have a house that's in process to be shipped to France. And so we really do have a worldwide footprint, as well as a really good understanding and expertise in working remotely, not just for building sites, but also in working with our customers. It's something that we are well used to doing over the 50-year history that we have. And we are still family owned, and this is important to us, that we still retain that that specialness of being a family owned. In fact, most of our customers we know on a first name basis, and we consider them as family. And I think they also consider us family based on the notes that they send back to us. And so that's very important to us that we are a family owned company, still located in Asheville where we started. The other critical thing is that we are continue to innovate, and that's important for us. The world is changing. Storms are becoming stronger. Certainly, the concept of sustainability is becoming much more sophisticated, and so we continue to innovate, much like we've done throughout our 50-year history, to make sure that we are continuing to build the best homes for you. The Deltec way is kind of guiding principles that we live out in our daily life and how we work within Deltec, but obviously how we work with you. And so, one of the principles is that we connect people with people. And so we design homes to fit your lifestyle, and it create meaningful interaction for you, whether it's your big events such as weddings or small intimate family dinners, are very important. That's a guiding principle for us. We also connect people with nature. So we blur the lines between what's inside and outside. We look at, how do we allow you to live better inside while connecting to nature. We also connect people with our planet. So we look at not just the next generation of home owners who might own your home, or you might be able to pass your home down to, but future generations. And so how do we create homes that withstand the generations? And through that, help reduce the footprint of our homes in the earth. We connect the home to our planet. So the materials that we use are really designed to create safe homes that can withstand anything that Mother Nature might throw at us, so that we therefore use those materials to create the best homes. I wanted to talk a little bit about kind of what every Deltec home includes, because it's really a hybrid approach. We have systems. We're a systems-built home engineering company that we build for strength and sustainability, that all of our homes are then custom designed for you. At the same point, we provide highly engineered, machine precision crafted homes with all the different component or connecting components to the dry end that you might need for your home, much like you see on the building on the left. And thirdly, they are assembled and completed on site with the expertise of a local builder to your local specifications and design preferences. So really what that means is that you get the benefit of a prefab, the flexibility of a custom built home, and the design and expertise of Deltec, which is why we have people like Leigha here to talk to you today. And so, this Deltec way, is how we can work, and it includes working through with you through every step of the process. And so these series of webinars are designed to kind of help you with that. And that's why I'd be very thrilled to introduce Leigha Dickens now to talk about high performance sustainable building to you. So with that, take it away, Leigha.
Hey, Scott, thank you. Thanks everybody for coming. So my background is in physics and environmental studies. And I think that's been a really great background to bring to green building, because I really get to apply science to something that affects everyone's everyday life, which is their home. And as such, I wanted to start off with a definition of a branch of science that has a lot to do with green building, which is called building science. And building science, I'll just read this definition here. This came from a builder in Texas called Matt Risinger, who has a really good blog series on green building. But building science is the collection of scientific knowledge and experience that focuses on the analysis and control of the physical phenomena that affect buildings. The practical purpose of building science is to provide predictive capability to optimize the building's performance, understand and prevent building failure, and guide the development of new design and technologies. So what it really is doing is looking at the house as a system. And this picture is sort of showing that. You've got all these different components of the home that seem like they aren't related, but building science is looking at how they do end up interacting with each other to affect your experience as the person in the home, as well as how does the home end up interacting with, the environment around it, and how does it impact the environment around it. So that's, the sciencey way of looking at it, but that's the way that I like to come at starting this process. The thesis of building science, and of course of sustainability more general, is that things could be better, right? And so specifically, homes could be built much better than they generally often are. And there's all kinds of reasons one could find. These are just some reasons that really spoke to me. One reason would be that in 2018, the energy use in residential buildings contributed 20% of all of US total carbon emissions. So energy use in buildings, including residences, has a significant impact on the environment. And if you look at buildings as a whole, not just residences, it's actually 40% of US carbon emissions. You couple that with the fact that we spend 70% of our time inside our houses, according to the EPA, and that's prior to the coronavirus. We're now spending much more time in our homes than ever before. And so, thinking about the environment we're exposing ourselves to every day and how healthy that is a really important component of green building and building science. And then on the durability and resiliency side of buildings, the 2019 hurricane season was projected to cause $14 billion in damages by the U.S. Central Budget Office, and that was on the resident side only. So certainly from a long-term sustainability standpoint, it doesn't make any sense to keep building things that just get knocked down in storms. So these are touching on many different aspects of sustainable building that people care about, like energy efficiency, air quality, or resiliency. And there are many others. And I'm going to touch on a number of different ones of those. When I talk about, what I'm going to do is go through some examples of Deltec homeowners and what they have done, the specific practices from the whole world of building science and green building that they have employed in their homes. So this is going to end up being an overview, I should say too. I could do in-depth seminars on many of these different technical topics, and obviously in the hour that I have, I'm not going to be able to do that. But I'm going to try and touch on a number of the key and some of the more common and prevalent strategies. So building science defines this concept of a higher performance home, which is something you'll hear a lot in the industry, paired with green building and sustainable building, is this concept of a high performance home. And the really, really general definition of that, of course, is a home that's built better, right? That performs better. But specifically, it usually means in the realm of comfort for you, the homeowner, durability of the home, the health and indoor air quality of the home, and in the home's energy use in terms of lower energy use, probably dramatically lower energy use than most homes would have, potentially even pairing that with energy generation in the home with renewable energy to further the sustainability of the home and further, increase its resilience and self-sufficiency in that way. An example here would be, Energy Star. This is a certificate from an Energy Star certified home. That's a program that has been put out by the Department of Energy to recognize homes that have features in them that make them more energy efficient. And then on the bottom, what I have is a piece of information from a HERS score, which I'll talk about in a little bit. That's like a score that assesses how energy efficient a home is on a scale from 0 to 100, with lower being better. They can predict potential energy savings from that home. So I've been working with Deltec customers for almost 10 years now on incorporating all these different ideas into their homes, a lot of times depending on kind of which things are more interest to them. And just some quick examples in different climates. This home was built in upstate New York. This is what I would call a high performance home. And it's actually also what I would call a net positive home. And so it's time to do a little bit of terms, because another type of home you might hear a lot about if you're doing any research in the green building industry is a net zero home. Sometimes called a zero energy home, but I think net zero is commonly used. And so what that means is a home that is incredibly energy efficient. So efficient that it becomes feasible for those homeowners to use renewable energy. In this example, you can see they've got a very large solar array in front of their home. And usually with net zero homes, those homes are not independent from the grid. that would be what's called an off-grid home. With net zero homes, those homes are usually interconnected with the power company. And they've usually entered in some kind of agreement. And more power companies are doing this, where they will basically let you, export your excess energy when you're producing more than you need and paying you for it. And then you still pay a power bill for whenever you draw energy when the sun's not shining. And the idea is your energy bill kind of nets out to zero. That's where the idea of net zero comes from. So these customers, Yosh and Nili, they were trying to do that, but they ended up overshooting because their home was so energy efficient that they ended up being net positive, because basically over the course of the year, they end up getting more back from the power company than they end up having to pay to the power company. So that's pretty nice for them. Next example, this is another home. This is in very remote and high elevation Colorado. And this home is an off-grid home. It is able to supply its own energy needs with fossil fuel propane backup. But it's actually using 3 different kinds of solar energy kind of all at once here. And so, and I'll go over a lot of those, but the first type is what's called passive solar design, which is where it's got south-facing windows in the living space that are trying to harness some free heating from the sun when it's shining in on those windows. The other type would be solar electric production, which they've got little solar panels here that are, that energy is produced by the solar panels and stored in batteries, and that home is drawing its electricity needs from those batteries. So it's actually not hooked up to the grid at all. And that was by necessity in their case because they were very far away and it was going to be very expensive for them to hook up. Then they also have solar thermal heating system, which is what these larger solar panels are. And those are solar panels that collect heat. They basically sit in the sun and get really hot, and the water in them is then run through the flooring in this home to help provide space heating. So different technologies brought together in this really sustainable home. And then this is another example. This is a home here near in Asheville, North Carolina. This is a treehouse. It's a home that's built up on stilts in a mountain environment, which was partially to protect the slope, because when you're building on a slope, it can be a more fragile ecosystem. This home is a Healthy Built Home certified home. That's a local North Carolina certification that you can get for a very good indoor air quality. And this homeowner actually decided to turn their yard into a World Wildlife Fund certified wildlife refuge. You can actually do that if you do a certain amount of plantings and things, that they have a guide for how to do that. So different examples in different climates that I just went through, as well as different sustainability goals, just to show you kind of the breadth of things that are out there that people would consider doing with their new homes. People ask a lot, why are your homes round? There's a number of reasons for that, but as a physicist, I will point out that there is actually an energy efficient advantage to having a round home. And that advantage comes with the fact that a round home has less surface area than a same-sized rectangular home would, as well as the better airflow characteristics of a round home. So why surface area matters is because, all of your walls, all of your roof, and to a lesser extent, your floor, those are all exposed to the outdoor temperatures. And that is where you have heat loss or heat gain. And heating and cooling bills are, in most homes, the largest energy expenditure. So there's obviously many strategies you use to tackle that, but one helpful thing is just when you actually have less surface area to begin with. And so this is an example, a model of 2 different homes. They're both 1,600 square feet of interior space. One's rectangular, one's round. If you actually did the math to add up the area of all the walls and all the little roof sections and everything, in this example, you would find that the round home has 17% less surface area, which is about 600 fewer square feet of surface area. So that's 600 fewer square feet over which you're having this heat transfer happen, which does just help make the home a bit more efficient. The other aspect of the round that is beneficial is, of course, the better airflow characteristics. So here's an example with a typical home of how if you have wind building up, it's going to build up pressure on one side of the home and not the other. And obviously that can be really significant in high wind situations. But even from an energy standpoint, this can make a difference, because what this can drive is air infiltration, which is, cold air seeping into your house, and then your heating system has to kick on to warm it up, and that spends more energy, and then vice versa in the summer. And air infiltration is really significant. According to the Department of Energy, between 25 and 40% of your home's heating and cooling costs, which once again are the biggest energy costs in a home, can be attributed to air infiltration alone. So reducing the amount of outside air coming in is a pretty important, it's one of the bedrock strategies for energy efficiency. So you have less drafts building up with a round home. And in addition, because our system is panelized, which Scott had talked about, which means we're building the pieces of your home in a factory, they're going to fit together more tightly as well. So you're already going to have a more inherently airtight structure because we have to get the tolerances really close. So I want to talk a little bit about how to measure energy efficiency, since it is one of the really important and most aspired to goals of high performance building. And this is interesting because, you know, if you were trying to compare the energy efficiency or the fuel costs really between two cars, you have a tool that helps you do that, right? You can look at the mile per gallon rating and you can know, man, if I buy this car, I'm going to be spending this much in fuel. If I buy this car, I'm going to be spending much less in fuel costs, assuming I drive the same amount. But if you're looking at trying to compare, you know, two homes to each other or potentially two new home designs to each other, it's not always easy to know that, you know, because there's a lot of variables that go into that. And so there is a tool to help make this easier for people. And this tool is called the ResNet HERS Index. So just some acronyms here. ResNet stands for Residential Energy Network. It's a nonprofit organization that obviously exists to promote energy efficiency, and they oversee the HERS Index. And HERS stands for Home Energy Rating System. So yes, that's exactly what it is. And it's a scale from 0 to 100 is kind of a normalized score because that is the score that basically a code-built new home would get. If it didn't have anything special beyond what the law says it's got to have, it would be about that efficient. That's what 100 means. It can go higher because you could have existing homes that were built prior to, you certainly do have existing homes prior to current codes that may even use way more energy than that. So the HERS score is lower means more efficient. Higher means less efficient. And so this is a score that it's possible to get done on a new home, even on an existing home. You basically have someone called a HERS rater come in and take a good bit of data about the insulation, the geometry, the windows, the heating, cooling systems, all the things in the home that contribute to its use of energy. They put it into this computer program that kind of normalizes this score. So 100 is baseline. That's like code-built new home. Lower is better. And this can be a tool then to potentially compare, you know, how low can I get my HERS score to go, basically. And I have a couple of examples along the bottom of showing you kind of the range of sustainable homes, just depending on people's goals. An example might be a HERS score of 75. You know, that could be seen as like that home is 25% more efficient than a standard new home. That would be something like a base level Energy Star certified home, which remember Energy Star is like a program for making a home energy efficient by doing a few extra things. The idea of a high performance home that I'm talking about a lot, I often see in the HERS 45 to 55 range. That means you've done a number of extra practices up front with insulation, with air tightness, with heating and cooling systems, water heating systems, et cetera, to really drop the energy use of that home compared to a traditional new home. And you can get lower than that. It starts to get harder to get lower than that after a while without adding solar into the picture, but the score does factor that in if you have renewable energy generation, and that would get you into the category of a net zero home, would be a HERS score of 0. So with that in mind, I'm going to go now in depth into 3 example Deltec homes. I'll show you their HERS score, and I'll show you some of the things that they did in more detail, just so you can sort of see some of these different practices. All right, the first example is a home that got a HERS score of 0, so it is a net zero home. This is a home that our own building company built here in Asheville, North Carolina. This is one of our Renew Collection Ridgeline models. This is a Ridgeline B, and they did a garage and kind of site built a little connector between them. So this home did a number of green building certifications, as you can see. It is an Energy Star certified home, but you know, it's really, since it's a HERS 0, it really got a lot more efficient than that. It's also an EPA Indoor Air Plus certified home. That's another green building program that focuses on health and air quality. And then it's actually a zero energy ready home. That's another green building program. There's so many green building programs, it can get kind of confusing. But the zero energy ready home is actually a pretty cool program to watch. It's a program put out by the U.S. Department of Energy with a list of requirements. Basically, to do any of these, you have to follow a certain list of practices during construction that are really targeted at that high performance home, that HERS 45 to 55 home. And then from there, it becomes really easy to add solar and become a net zero home, which is actually what you can see that these homeowners did. They've got their solar array there. So this home, it was a retirement home for a couple. They were looking at trying to have, single level living, low maintenance, all those things that people kind of want when they're trying to downsize and simplify their life a little bit. And they also wanted to live more lightly on the planet. They didn't necessarily know a lot about how to do that, so they used the guidance of my department when they were working with Deltec to make a lot of decisions that really resulted in them being able to do all these cool certifications when they were building their home. So I mentioned this program, their Zero Energy Ready Home program. There are a number of green building programs, and I think this is one of the most relevant to residential new construction. People ask me a lot about, what about LEED? That's a really commonly known green building program, and that's a good program too, but it's a lot more applicable commercially than it is in the residential market. And so this home actually won, it was an award winner of the Zero Energy Ready Certified Homes in 2019. Ours won a Housing Innovation Award. And of course, the Department of Energy talks about all these benefits you get when you do this sort of sustainable building techniques that they recommend. Healthy environment, comfortable, advanced technology, super efficient, quality, and durable. And they're sort of comparing what it's like for you as a homeowner with a Zero Energy Ready home versus like even an Energy Star home and just a code built home. So because we won that award, the Department of Energy actually did a case study on their website of this home. So if you Googled US DOE Tour of Zero, that's what they call it, then you would be able to find a bunch of homes that they've done a case study of, and you can search within there for Deltec, and you'll see this home that I'm just showing you pop up. And this is an excerpt from that where they've just kind of given some cool stats about it. So HERS Zero, $20 average monthly energy bill, that's basically like what you've got to pay the power company to be hooked up at all. Significant annual energy savings, but I think it's really interesting that they totaled the savings that home is going to achieve in the first 30 years of its life, which is almost $75,000, which is, pretty amazing. So some interior shots of what that home looks like. And then now let's get technical and talk about some of the stuff we did to get that low HERS score, all that stuff. One of the things that they did was they used our energy wall, which is an option that we offer that, as the name implies, is trying to be a more efficient wall. And this diagram is really busy. I apologize for that, but it's sort of showing you that we're putting a lot of thought into this, what seems like such a simple concept, which is just building a wall. But when we do that, we can really make that wall a lot more energy efficient than is standard. And so many features are of this wall, but one of the ones I'll point out is our use of exterior insulation. And let me see if I can get the drawaway thing to work here. I don't think I can mess with that. So I'm just going to click through. But this is what this layer of foam insulation is on the outside of the wall. So it's kind of showing you behind the siding, but in front of the framing. And it is an R5 insulation. So we call it R5 thermal shield. And so when you're talking about insulation, R value is a measure of how insulated something is. The higher the R value, the more insulation. So this is cool. It gives you +5 to your wall on top of the normal method of insulation, which is to put, bats or whatever material you would put between the studs, which you still do that, but you have this on top of that as well. But because this is on the outside of the wall, it gives you an even greater benefit than that. And so these is demonstrating that here with 2 images from a thermal camera. The picture on the left is a Deltec home that has that R5 thermal shield on the outside, whereas the picture on the right is a home that does not. It only has insulation between the studs. So the bright colors mean that it's something that's giving off a lot of heat, so it's not insulated very well, versus the dark colors mean something is better insulated. So right here on the right, you see all these lines. Usually if I'm actually in person with people, I'll ask them, what are those lines? And people will say, well, those are the studs, because yes, those are the wood studs. The point is wood is a great material. It can be harvested very sustainably. It, holds a house up well, but it doesn't insulate very well. So this R5 thermal shield, it basically acts like a blanket on the outside of the house, and it's adding insulation over the entire wall, even including the studs themselves, which, as you can see, really reduces the total amount of heat that's coming out of that wall. Another feature of the energy wall, and this is one that being a panelized company makes us able to do, it'd be really hard to do this on site, is we put a gasket in the energy wall between the wood studs, which is what Victor here is putting on the perimeter of the wood studs of a wall panel, and the plywood sheathing, which he's going to next take the plywood from this pile in the back and put it on. And that foam kind of slowly expands, and it's going to make this airtight gasket between those two building materials, which is going to just help even more increase the airtightness of that structure. And I mentioned before how important airtightness is, how air infiltration is such a big portion of utility bills. And this is just another tactic to try and reduce that. And so this photo here, this is not a time machine. This is what's called a blower door tester. And it's a contraption that you can use to actually measure the airtightness of your home. What it will do is it will end up quantifying like the size of the equivalent hole that's in your house. And that can be kind of scary sometimes if you do this test in like older homes that are really leaky. But this is a test that if you're doing, for instance, if you're getting a HERS score done on your home, or if you're doing any of those green building programs, they're going to require you to do this test to quantify how tight the house is. And so we do these tests a lot on our homes, and we get very good scores because of all the different things I talked about, panelized construction, that gasket, as well as, working with our homeowners to really pay attention to caulking and sealing during construction, all the different possible places. We typically get tests that are 3 to 5 times more airtight than you're going to find in typical new construction. Sometimes even more than that. It kind of depends on how far you want to take it with going through and trying to find all the holes to seal up during construction. Another piece of our energy wall is insulated headers. You may be wondering, what's a header? Well, I've got a picture of them right here. Here's some boxes of wood. But in a typical construction, what a header is it's a structural component that goes above windows and doors to help kind of direct the structural load away from the window and door and to the framing on either side of it. And in the Deltec round home system, we actually have headers in the top of all of our wall panels. This is a photo on the right, is a photo from like a little example mock-up panel we have in our plant that's showing you, again, all the layers of the wall. The stud framing, that gasket is shown, this little black picture frame, and then you got sheathing, foam, house wrap, and then siding. And then this header is this thing running across the top. And that's part of what makes our round home so strong, is this header. And so if you want to find more engineering details like that, then you can tune into our next presentation, which is going to be about precision engineering. So anyway, headers are an item that in typical construction are usually not insulated. They're usually just kind of a box of wood, which again is another weak spot. And so we take chipped up pieces of that scrap material, of that R5 thermal shield material, and we put them inside of our headers in the factory. So we are insulating a material that isn't normally insulated in construction. And we're also using a waste material to do that, which is, repurposing and trying to be more material efficient as well. Since I keep talking about how important airtightness is, I've got to address how that relates to air quality, because that's a really important thing to keep in mind. And so what these homeowners did, and what a majority of our homeowners do, is incorporate mechanical fresh air ventilation. I could do an entire webinar on indoor air quality, and if there's interest, I'm actually thinking I might do that later this month. But of the air quality measures to take, I think mechanical fresh air ventilation is like the bedrock measure. And what that is a separate mechanical system as part of the home systems that is deliberately bringing fresh air into the house. And we do it with what's called energy recovery ventilators or heat recovery ventilators. So those are mechanical units, and those are balanced. So they bring fresh air into the house through a dedicated duct. They circulate that fresh air throughout the house. And then at the same time, they also pull stale air from the house, run it back through this energy recovery ventilator to kind of get some of the heat back out of it, and then expel that air from the house. So it's just breathing in and out for the house, like lungs. And the reason you want to do that is because yes, I keep talking about how air from the outside, raises your energy bills, and it does, but you do need a certain amount of fresh air to dilute indoor air pollutants and to make sure that your air stays healthy. So when you're doing it with this system, what you're doing is making it happen at a controlled rate. Instead of having a house that just leaks like a sieve, air all over the place, you are bringing in the amount of fresh air that you need and not more than that. And the way that that's calculated through an engineering standard that looks at the size of the home, the number of bedrooms, and kind of comes up with the amount of airflow that you need. In addition, this is a better system too, because instead of that air leaking in from who knows where, maybe your crawl space or your attic, where that air is maybe not so healthy, you have a dedicated and clean input location where that air is coming from. You're controlling the source. You basically just have an air intake on the side of your house where you get that from. And then the reason I talked about the heat exchange part, these energy recovery ventilators and heat recovery ventilators actually have a heat exchanger inside the unit. So you're kind of like taking some of the heat that you've already spent to heat the air that you're pushing out and then putting it into the incoming air. So it's not as much of an energy penalty as if you were to say, open your window on a 20-degree day. So really the whole point of these systems is that you do need some fresh air to make sure that your indoor air quality is healthy. But doing it this way is adding, it's adding a mechanical system, is making it very controlled. And you can add different levels of filtration into the system as well to further improve your air pollution or your health outcomes, just depending on kind of what you're sensitive to. But that would be, in the more advanced discussion. Green building certification programs, I talked about how this example home had 3 of them, and I do think that they're really important. I know a lot of people will say, well, I'm just going to follow some of these recommended best practices, but I don't know if I really want to bother participating in one of these programs. And I'm just going to put a plug out there that I think these programs are really important because they're really giving you quality assurance. Like, you're not just doing a bunch of things when you're building your home because I said so. You're doing them because there's a system, like a program that kind of highlights the best ones to do and why they're important and why they affect each other. And so that's one thing I like about them. These programs are based on building science. They're based on research in past homes with, what works and what actually doesn't and what maybe creates problems if you're not careful with pairing things together. And when you do one of these programs as well, you're going to have some of those tests that really help, like that blower door test, to actually test how airtight the house is. You're not just, sealing stuff up and hoping, you're actually getting a quantified score. As well as, of course, if you participate in one of these programs and you're supporting industry, you're supporting programs that are designed to make the industry better and doing it in a really systematic way. And so I think that that's really important to contribute to while you're contemplating building a sustainable home. People sometimes ask, okay, are there rebates out there for green building? And the answer is maybe. It depends on where you are. If you're building in a city, maybe. And if you're building in the middle of nowhere, probably not, but we can look and see. However, just a plug that we do offer, Deltec offers rebates to our clients if they participate in one of these green building programs with their builds. And so there's sort of a tiered structure based on the difficulty level of the program that you choose. But if you send me your certificate showing you that you've gotten the program on your Deltec, then yes, we will give you a rebate check. And the details of that are on our website. But we are trying to make it something that our homeowners are really encouraged to do. So my next example, this is a home also near here in Asheville, North Carolina. I like to joke that these people just love the color green. But this home is one of our 360 collection homes. It's also an Energy Star certified home. It has a HERS score of 38. And just for size reference, this is our 1,200 square foot model round home. And it's on a walkout basement. I know you can't tell in this picture because you're sort of looking at the front, but it's kind of built into the hill. So there is a walkout basement that has some additional square footage. So it's probably about 1,600 total square feet of living space. And so this was a younger couple, Jim and Adriana. This was both their home, and they both were going to be having home offices to work out of their home. So they really needed the energy systems in this home to be super, super low energy, and they really wanted this home to be super sustainable. This is a photo of the interior of that home. And then here is a photo of the model that Jim built fully to scale of the custom round home that he wanted to have, including the little to scale model of him and Adriana. And he brought that in and said, okay, guys, here's the house that I want to have. And then here is Adriana on the job site, kind of holding that little model up. So I'm just going to pause here and say this is not a skill set that you have to have. Although if you want to, if you're interested, if you want to get some corkboard going, you can go for it. Jim is a draftsman by trade. We are able to take, ideas that you want to have in your home and put them in paper and, turn them into actual working floor plans. But I thought this was pretty cute. So what Adriana is doing here, she was looking at the overhang. She was trying to understand how the sun angles were going to affect her job site because they were really interested in passive solar design. And so what I do, I can help people with passive solar design. That's one of my favorite things to do. So this is my version of her home, but looking at it with some software. So I mentioned passive solar design before. What it is a way of laying your home out to take advantage of the natural movement of the sun in your climate to have potentially some free heating, maybe potentially some passive cooling. And I like it because it's not like a fancy technology. It's not like another system you're sticking in your home. It's just the way it's designed. And so in this climate, which is, considered a mixed humid climate where it's cold in the winter, it's hot in the summer, it's humid a lot, passive solar can be an appropriate strategy, but you don't want to overdo it in either direction or you could end up kind of uncomfortable. So what we did here is I looked at her home, and I'm going to see if I can get this drawing thing to work again because my head's in the way. Well, I'm going to get the drawing thing to work. So I looked at her home. I looked at it on the winter solstice, which is when the sun is going to be the lowest it will ever be in the sky. And I looked at the shade line above her windows. And these are the living room windows, which is going to be the biggest room, like you saw the picture. And what I was able to see is that the shade line from the overhang wasn't shading those windows. And those sunbeams, which you can kind of see on the floor there, were able to penetrate into the space. So that basically means that throughout the day in the winter, they're getting a lot of direct sun shining into the living room, which can just help, heat that space up a little bit, reduce how hard their heating system has to work, which reduces their energy bills. Oh man, I lost the, what did I do here? I lost my ability to advance because of the way I set it up. Oh. Come on, here we go. Okay, sorry about that. So this is the same view, but it's now on the summer solstice. And the sun is now, the highest angle that it will ever be. And so now I can see that her entire wall is covered in shade, which basically means that overhang is long enough that it's blocking the sun from penetrating that space in the summer when all that heat would certainly be unwelcome. So that's one aspect of passive solar design. It's south-facing glass, the right amount of south-facing glass, not too much and not too little, to get that right balance as well as the right overhang length. This is another shot of the interior of that. And the other thing I want to point your attention to is another piece of passive solar design, which is called thermal mass. And that is exemplified in their floor, which you can't quite tell in this picture, but what they have is a stained concrete floor that they've put in. And concrete is a great example of thermal mass because it's a very dense material. It takes a long time to get heated up and a long time to cool off. And so having that floor where the sunbeams are going to land on it is going to help hold on to that heat in the winter and then slowly release it at night and then kind of be a heat sink in the summer to help that space from getting too hot. So it really helps modulate the temperature in that space. And that's another core principle of passive solar design. You combine that with, extra levels of insulation, very airtight design, you can be really powerful in how much you're reducing that home's heating and cooling needs just by the design of the home before you even get into like fancy mechanical systems and things like that. This is another shot of that home during construction, and you can see they love the color so much that they asked us to stain all their wood green. What that is a non-toxic mold and termite resistant framing treatment, which is something that we are able to do in our Deltec plant. Here is a shot of the structural component, this in case of floor truss, being run through a flow cutter machine. that we have to do that. And so what that does, that it's got some moldicides and fungicides within it, as well as a mineral called borate, which is a mineral that termites don't like to eat. So it basically makes the board not taste good to the termites. And so it's a non-toxic way to keep them away from the home. It's not a substitute for also having regular termite contract, but it can be a really good long-term durability strategy. And the green is just a dye so that you can tell wood that's been treated from wood that hasn't. So that's something that we offer. It's called Frame Guard, and it would be something that would come on all the structural components of your home. All right, our next stop is going up north now to Bellefonte, Pennsylvania, which is really close to State College, with another 360 collection home. This home, Energy Star certified again, HERS score 39. It is a larger home. It's a 2,000 square foot round model with a wing and a garage. It's actually also on a fully conditioned basement that's also about 2,000 square feet. So it's a little over 4,000 square feet of living space. This home is a home of an environmental engineer. So he really wanted to get really technical and nerd out about lots of fun stuff, solar heat gain coefficients and lots of cool stuff. So I really enjoyed working with him. And here's a shot of the interior of that home as well. And so Chris used a strategy, especially being in a colder climate, called super insulation. And really, even the first home I give you was an example of that too, because he was in a colder climate, he took it further. And that just means insulating the heck out of something, you know, way more than code minimums, because insulation is a relatively inexpensive building material compared to other things, and it lasts the lifetime of the home. So this is our double stud wall, which is what Chris used. It's another option. It's a step up from the energy wall that uses 2 layers of 2x4 studs instead of the conventional 1 layer of 2x4 studs, even with some space in the middle for additional insulation, as well as all some of the other features of the energy wall. So he's more than double, basically, his insulation compared to code minimums. He did a similar thing in his roof with some trusses that we have that are built up to allow more space for insulation. And he also used triple pane. I know you can't tell in this picture, but he used triple pane windows, which 3 panes of glass to help really reduce their thermal loss. So the other thing Chris did that actually all of our homeowners did was he used our machine finish siding process. And here's a picture of a piece of fiber cement siding, which is the most common siding that we see people using because it's super durable and very low maintenance and looks, has a nice wood looking look to it. So with that same flow coat machine we're able to coat our boards with paint in the factory. So we can actually send your wall panels in the round home with the siding pre-installed and pre-painted, which is nice and fast for you. And it can be, we can do all the different Sherwin-Williams colors. But the benefit of doing that in the factory is that we're coating all 6 sides of the board with paint, even the back, to help protect it against moisture. And so when you do that process, it actually offers a 25-year warranty on the life of the paint job, which is pretty low maintenance, which is pretty nice. Another thing that Chris did, this is a different shot of his home from a different angle. You can see that he did add solar electricity. He had a pretty big solar array to his project as well. And here's just another shot of a Deltec homeowner who's added solar electricity as well. So we don't sell solar electricity. That's not what we do. We provide the structural shell for your home, but it's kind of hard to talk about green building without talking about solar in many respects. And so it's something that I end up talking to people about a lot. You can even put it on the round roof if you'd like to do that. And so the thing about solar, for some people, it's kind of the holy grail of green building. It's something that potentially could enable you to go off grid if that's something that you're interested in. And we're seeing an uptake in interest in that. And it's just something to realize about it. It's very scalable. You can do a small grid tied system now. You can add more to it later. I've seen pre-wiring for future solar being really popular. It's more affordable than ever. There are still some federal tax credits available, and depending on where you're building, there can be utility rebates or state rebates. And then another thing that I'm seeing that's really popular, especially in the design phase, is thinking about future battery backup, because that technology is becoming more viable and more affordable so that maybe you're looking at a future where instead of being totally off grid, what you're doing is you're going to, plan for a future solar array and plan for a future use of one of those whole house battery systems that enables you to, store your solar energy and have it in time of need, but still have access to the grid. And there's definitely some kind of long-term resiliency benefits in doing that. So if solar is something that you're interested in and all these different setups, that's certainly something I'm very well versed in. My undergraduate research was actually in solar, so I love talking to people about all these different options. But when you're considering solar, I just have to remind you once again of the power of energy efficiency, especially in the context of a new home. And so imagine for a minute the typical American home, not a new home. Imagine how old it probably is, how leaky it probably is, and how much energy it probably uses. And the technology exists to power that thing with solar. It's not really a technology question anymore. But what you might find is the solar array that house needs is kind of untenable. So once again, every amount of effort spent in the design phase towards making the home more energy efficient, making it need less energy to begin with, only makes the possibility of energy independence with solar easier, because a new energy efficient home is going to need a much smaller solar array to provide power for it. So something people ask a lot, but they don't ask it this way, is, Leigha, all that green building stuff is great, but it seems like it's just really expensive. And I'm going to turn that on its head and throw the concept out there of how much cheaper is it to build green, really? Especially when you're thinking about the long term, about the resiliency and the low maintenance and the low energy bills, and of course the environmental impact as well. And obviously every custom home is different. And every single person who builds a Deltec home builds a different house in a different place. And they're all going to have different energy bills because they're all going to have put different stuff into their house. But I do have a tool that I use a lot with clients, which is energy modeling through that HERS score system, where we can actually look at the different design decisions that you've made or considering making in your home. And we can sort of predict, well, what is the resultant energy bills going to be? And so I did some energy modeling comparing these two kind of hypothetical homes that I've been talking about, that typical American home, that existing home, HERS 150, and your new high performance home in that HERS 40 category before you even consider adding solar to it. And then in this area in Asheville, which is not as in some ways a milder climate than many of you are building in, but is kind of a good average too, because again, we're mixed humid. It's hot in summer, it's cold in winter, it's humid all the time. So around here, this existing home might have energy costs $300 a month or more, versus this new home is going to have much lower energy bills a month. And that's already equating to $3,000 a year in energy savings. And that's before you even add solar to the picture. Obviously, that picture is different for every home, just pointing out the power of energy modeling and making some of those decisions. And in thinking long term, thinking about the total cost of ownership when you're building a home. Another way to look at it, of course, is who would you rather be paying? Yourself, putting a little more money up front into extra insulation, more than you strictly are required to by code, into that better heating system, into that green building certification, versus shelling that money out down the road forever to the status quo. That's another way to look at it. We have gone solar ourselves. This is the roof of our manufacturing facility. That's Steve Linton, our president, pictured there. That was back in 2007. So at that point in time, we installed a solar array with 273 panels. It's a grid-connected solar array. And it was at the time the largest solar array in North Carolina. And we were super proud of that. But that was back in 2007. And solar has definitely grown like crazy since then. But we still have it. It's still providing a portion of our energy. We get the other portion from wind power offsets. So we are actually a 100% renewable energy powered facility. So that's cool assurance that when you build with us, not only am I going to help you build a more sustainable home, but the way that our homes are built, our manufacturing process is also something that as a B Corp, we are optimizing to be as sustainable as we can make it. Another piece of that, of course, is waste. One interesting benefit of panelized construction is the ability to reduce the amount of waste associated with the project. we are building our home in a factory where we are able to, utilize our materials together a lot more efficiently. And so one of the things that I look at is, how much waste we are producing. And we have different programs like reuse programs, donation programs, recycling programs. And through those programs, we are able to divert over 80% of the waste from our product from the landfill and have it go, somewhere back into the reuse stream. And then some other things, one of the handouts that I have for you is our sustainability report, which goes into a lot of detail. It has some case studies on some homes. It's got some facts about energy efficiency and certification and all kinds of cool things. So I just pulled from that. Again, at 80%, we're able to donate average 80% of our waste material. We're able to divert it from the landfill. The average HERS score that I have on record for Deltecs that have come back to me and said, hey, I got a HERS score done and this is my HERS score, was a 45. So our average home is in that high performance category. And as Scott had mentioned, we are certified B Corp, which is kind of like a green building certification program, but it's a program that businesses have to go through, where we submit our, environmental practices, our corporate practices, how we treat our employees and how we treat our customers to some scrutiny. And we have to meet a checklist of requirements and to be able to earn the right to call ourselves a B Corp. So I'm going to finish just with the note that obviously sustainability means different things to different people. And if you haven't already, I had put a poll out where I asked you to, I listed some of the common, ideas associated with green building. And I was just kind of curious, which ones are the most important to you? Because I know that varies. I work with clients with all kinds of different goals. So I just kind of wanted to throw out what it means to me with this photo of this beautiful spot that we're social distancing, so we can't go to right now. But it's on the Blue Ridge Parkway. It's a beautiful spot in the mountains. And of course, part of the reason that I do what I do is because I want to preserve spaces like this for future generations. But I do believe connectedness to these kind of spaces are important. And then, of course, but the other reason, and this is kind of a joke, but building physics. So I mentioned that my background is in science, I'm in physics, but I really basically like taking ideas of science and technology and applying them in a real world way to this question of how to make homes better. I find that really inspiring and really interesting. So with that, I will thank you all for your time, and I hope to hear more from you as you work with us to design and build your green homes.